Hello everyone. In today's video, we are going to solve an equation where we have a cubic polynomial on the left hand side and a radical expression on the right hand side. So the first thought that you will be getting when we see such kind of questions is to get rid of the radical symbol, right? And how do we do that? We have to square the equation on both sides, isn't it? Let me rewrite the equation. X cube minus 3x equal to the square root of x plus 2. So let's go on and square this expression on both sides. So this side squared and this side squared. So what do we get? So on the left hand side, you can expand this using the formula a minus b whole square. That is a square minus 2ab plus b square, right? So a square will be x cube the whole square minus 2ab will be 2 times x cube times 3x plus b square will be 3x the whole square. Okay, and on the right hand side we get x plus 2. But one risk that we have when we square the radical is that we can introduce some solutions that will not satisfy the equation. Why am I telling this? Suppose we had the equation something like x cube minus 3x equal to minus root of x plus 2. So when you square this equation both sides, you will get the same expression that we have here. Okay, but this one is not the question that is given. It's a different equation, right? So we might introduce some solutions that they are called as extraneous solutions that will not satisfy this equation. But anyway, we will take a look at what we get now. Now let us go further. X cube the whole square is x power 6 minus 2 times 3 is 6 times x cube into x is x power 4 plus 3 square is 9 and x square is x square. I'll bring these two terms to the left side so that we have minus x minus 2 equal to 0. So now we have got an equation of degree 6 that is called as an hexic equation. But how do we solve this? We don't have any standard formula to solve. We can make use of something called as rational root theorem to solve this equation. So that is a trial and error method actually. So what we have to do, we have to look at this coefficient term that is minus 2. We have to find out the factors of minus 2, both positive and negative, and we have to plug all those values in this equation and see which one will give us 0 as the answer. So I can say that minus 2, it has factors as plus or minus 1 and plus or minus 2, right? So these are the numbers which can divide minus 2. That's why they are called as the factors. Now you can plug all these numbers in this equation, and if you do some trial and error, you will find out that x equal to 2 is a solution. X equal to 2 will satisfy this equation. Okay, that you can do by trial and error. So it's good enough. We have one solution, but is that the only one solution? No, right? Because it's a 6th degree equation, so it can have many more solutions. But one thing is that since x equal to 2 is a solution, we can say that x minus 2 is a factor of this polynomial, right? So if you divide this polynomial by x minus 2, you will get another factor. Okay, we are supposed to find out that factor, and we can do that by division, right? There are many ways to divide these two polynomials. I would prefer synthetic division. That's a very fancy method and very easy method actually. So let me introduce that method here. So as you can see, we have to put two lines like this, and outside these lines we have to write this 2, right? Because x is equal to 2 is a solution, right? So we have to write 2 over here, and inside we have to write the coefficients of this hexic polynomial. Coefficient of x power 6 is 1, right? And we have to write the coefficients in the decreasing order of the degree. After x power 6, x power 5 should come, but it's not there. So since x power 5 is not there, we just simply write 0, because 0 into x power 5 is nothing but 0 itself. And x power 4's coefficient is minus 6. And we don't have an x cube term also, so we have to write 0 again. X square's coefficient is 9, then x coefficient is minus 1, and we write the constant term also. Now how do we do the division? We bring this 1 to the denominator, and we have to multiply the 2 to whichever number which comes in the denominator, and we have to go on adding. 2 times 1 is 2, right? Now we have to add 0 plus 2 is 2. Then again multiply this 2 with this 2. 2 times 2 is 4. Minus 6 plus 4 is minus 2. 2 times minus 2 is minus 4. So we have minus 4 again. 2 times minus 4 is minus 8. So we get 1. 2 times 1 is 2. and we get 1 when we add 2 and minus 1. Finally, 2 times 1 is 2 and we get 0. So the last number that we have is the remainder. Obviously, we have to get the remainder as 0 by the factor theorem because we are dividing by the factor, right? We are dividing the polynomial by its factor. Now, the result will be given by these numbers. Okay, these numbers represent the coefficients of the result, that's the quotient, in the decreasing order. So you can see that the order, or I can say the degree of the polynomial, which we divided was 6, right? It was a hexic polynomial. So when we divide this hexic polynomial by a linear polynomial, the degree should be 5. The highest degree should be 5. Or else what you can do, you can go on writing from the end, right? So 1 should be the constant term, then this should be the x term, 1x. So it should be, we should put a plus and write x. And here minus 4 is the coefficient of the x square term, so we write minus 4x square. So we have to write a plus here also. And then minus 2 is the coefficient of the x cube term, minus 2x cube, and 2 is the coefficient of the x power 4th term, and 1 is the coefficient of x power 5. So this now is the second factor of the polynomial. Now we have to equate this to 0 definitely, because this second factor, since this is equal to 0, second factor is equal to 0. But how do we solve this equation? Now this is an equation of 5th degree. Again, we don't have any direct formula. You can use a rational root theorem. So again, we have to take this last number, that is x equal to 1. We have to take this number 1. We have to find out the factors, both positive and negative, that is plus or minus 1. And the thing is, if you plug in plus 1 or minus 1, you are not going to get 0 as the answer. So because of that, we cannot factorize this polynomial further. So we are not getting any solutions by this. Okay, so what can be done? So that tells us that this method will not work. Okay, this squaring method is not going to work because we are not getting more solutions. We are getting only one solution, that is x equal to 2, but there can be more solutions also. So at the end, I'll be showing a graph that will tell you that, will show you that there are more solutions here. So what is the other method that we can follow? So I have another creative method where we can take the help of trigonometric substitution to solve this equation. So let me bring this equation once again. So I have the equation over here. So we have to make some trigonometric substitution for x. So I am going to replace x with 2 cos alpha. Okay, alpha is the angle. Now why 2 cos alpha? Because here you have 2x plus 2, right? So that's the main reason why I have 2 cos alpha there. You will understand why it is 2 cos alpha, when we solve it further. Let us substitute x as 2 cos alpha in this equation. So x cube will become 2 cos alpha the whole cube minus 3 times 2 cos alpha equal to the square root of 2 cos alpha plus 2. Now 2 cube is 8 and cos alpha cube is cos cube alpha minus 6 times cos alpha, that is equal to square root of, I would like to take 2 common factor. So we have cos alpha plus 1, or I would like to write it as 1 plus cos alpha. Either way it works. Now on the left hand side, I would like to take 2 as a common factor, so that we have 2 times 4 cos cube alpha minus 3 cos alpha, that is equal to the square root of 2 times 1 plus cos alpha. Now some of you might recognize this expression. This is the expression for cos 3 alpha. It is an identity. Okay, so let me write it here for your reference. Cos 3 alpha, right? Cos 3 alpha is nothing but 4 cos cube alpha minus 3 cos alpha. It's the identity. And what is 1 plus cos alpha? We do have a formula for 1 plus cos alpha also. We get that by using this formula, that is the expression for cos 2 alpha. Now we know that cos 2 alpha is nothing but 2 cos square alpha minus 1. So what I do, I am going to half the angle on both sides. I am going to divide angle by 2 on both sides, so that we have cos alpha is equal to 2 cos square alpha by 2 minus 1. Now we take this minus 1 to the left side, so that we have 1 plus cos alpha equal to 2 cos square alpha by 2. So we are going to make these substitutions. So in the place of 4 cos cube alpha minus 3 cos alpha, we are going to write cos 3 alpha. Okay, let's do that. So here this will be 2 times, and this whole expression is nothing but cos 3 alpha, that is equal to the square root of 2 times 1 plus cos alpha is 2 cos square alpha by 2. So let's try to simplify this further and see what we get. So here we have 2 cos 3 alpha equal to square root of 4 times cos square alpha by 2. So we get 2 cos 3 alpha equal to square root of 4 is 2, and square root of cos square, this square and this square root will cancel out. So square root of cos square alpha by 2 is nothing but cos alpha by 2. So we can just cancel these 2's, and finally we get one result here, that is cos 3 alpha equal to cos alpha by 2. So with this, can we say that 3 alpha is equal to alpha by 2? Well, the answer is no. We cannot solve the trigonometric equation in such an easy way, right? Why? Because cos is it's a oscillating curve, right, where the value of the cos repeats after every 360-degree period, or 2 pi, right? That means we can write this cos alpha by 2 as cos alpha by 2 plus 2n pi, because 2 pi is 360, right? So after every 360-degree period, the same value of cos alpha will repeat. You must have seen the graph, right? So the graph will look something like this. So this is 0 and this is 2 pi, right? After 360-degree rotation, you can see at 0 this was the value, at 2 pi this is the value. In the same way, you can see if this is the value at this point, after exactly 360-degree rotation, the same value will repeat, right? So that is why we have to add that 2n pi. Okay, and we have another case also. What about the negative side, negative values? We also know that cos alpha by 2 can also be written as cos of minus alpha by 2, right? Okay, I wrote that alpha by 2 as 2, so it will be minus alpha by 2. So we know this fact that cos x is the same as cos of negative x. So minus alpha by 2 should also be considered, and the same thing, rotation as well, 2n pi. So we have two solutions that are there for alpha. Okay, we can get them by equating both sides. So 3 alpha can be equated to this, and 3 alpha can also be equated to this, right? So we can have two types of solutions. That is, one is 3 alpha is equal to alpha by 2 plus 2n pi, or 3 alpha is equal to minus alpha by 2 plus 2n pi. So if you want to get rid of the 2 from the denominator, you can just go on and multiply both sides by 2. Okay, multiply both sides of the equations by 2, so that we can get rid of the 2 from the denominator. So what do we get? 2 times 3 alpha is 6 alpha equal to, when you multiply 2 with this alpha by 2, this 2 will cancel out. So we just have alpha plus 2 times 2n pi is 4n pi. The same thing happens here. We get 6 alpha is equal to minus alpha plus 4n pi. Okay, we bring this alpha to the left side. 6 alpha minus alpha will become 5 alpha, that is equal to 4n pi, and alpha will be 4 pi. I will write pi together with 4 by 5 and into n. And here also we get the same result. I mean, a little bit difference will be there because minus alpha is there. So we have 7 alpha is equal to 4n pi. So we get alpha is equal to 4 pi by 7 times n. Now we have alpha, right? We have to calculate x. For that we have to get alpha. Now we have n over here, right? So we have to check some values of alpha for specific cases of n. Let's say n is equal to 0. If you take n is equal to 0, from both of these conditions, you get alpha is equal to 0 when n is equal to 0, right? Because 4 pi by alpha, 4 pi by 5 into 0 is 0, and here also it will be 0. Now what if n is equal to 1? Let us see the case where we get n is equal to 1. So we have one value of alpha as 4 pi by 5, and then here if you substitute n as 1, we get 4 pi by 7. So we have two solutions, okay? And actually alpha is equal to 0. What solution does that give us for x? So we had substituted for x, right? So if I go back over here where we started, we had substituted x as 2 cos alpha. So we have to go back to that substitution and recheck. the values of x, right? So x is nothing but 2 cos alpha. Now from the first case we have alpha equal to 0, so the one solution will be x is equal to 2 times cos 0. That's nothing but 2 times 1, right? Cos 0 is 1. So if alpha is equal to 0, we get x value as 2. So this is one solution, and if you remember, we get the same solution from the previous method as well, isn't it? Now what if alpha is equal to 4 pi by 5? So if we take alpha is equal to 4 pi by 5, we get x is equal to 2 times cos 4 pi by 5. And you can work out this value. This value of cos 4 pi by 5, it is somewhere around minus 0.8. It's a negative value. So we get minus 1.6. This is an approximate value, not the exact value. And if we take the other value, that is alpha is equal to 4 pi by 7, if we use that value 4 pi by 7, we get x is equal to 2 cos 4 pi by 7. So cos of 4 pi by 7, that value is approximately around minus 0.22. Okay, so this is that value. So we get approximately minus 0.44. Okay, so we have three values. What are those values? That is x is equal to 2 comma minus 1.6. This is an approximate value, and this also is approximate, minus 0.44. So these are the only three values we get. Why am I saying only three values? You can understand this when you see the graph. So let me show you the graph finally before we end this, so that you can understand the solution better. You can see this is the graph that I have plotted using Desmos calculator. So the blue one is the graph of the left side part, that is x cube minus 3x of the equation, and the brown one is the right hand side part, square root of x plus 2. As you can see, these two curves are meeting at exactly 3 points, right? This is 1 point, and this is 1 point, and this is the third point. So how can I be assured that these are meeting only at 3 points? Because you can see that this cubic function, the blue one, it is rising faster than the square root function, right? It is rising faster, so they will never meet again after this point. So you can see that this point, it is indicating 2, right? So x equal to 2 is one solution. And this point over here, it is somewhere over here, right? It's indicating towards that point. So this point indicates minus 0.44. That's our third solution. And you can see this one is pointing us approximately towards x equals minus 1.6. So these are the three solutions from the graph, and the only three solutions. So that brings us to the end of the video. And I hope all of you enjoyed the video and understood the logic behind solving this question. For more such interesting videos, kindly subscribe to my channel, and I will see you all in the next video.